Alright guys, last one, number 6. And again, we really haven't looked at any 6s, but the content is, we've looked at a ton of them. We just haven't looked at, the exact problem. So here's number 6. This one happened to be 1.08 was the average, which is a little bit crazy, especially after you look at it and you see what's being asked. You're going to go, wow, I could do that one. But anyway, here we go. It's actually off the screen right now, I think, the answer. So we got corn tortillas, and you really need to look at this. So if you haven't read through the problem in great detail, read through the problem first, and then pause this, read through it, and then come back and try to answer the questions. Then look and see what I did. At least think about it ahead of time. It'll help you be better prepared. Okay, so we've got two production lines, A and B for tortillas. One of them has a mean of 5.9, one has a mean of 6.1, and they each make 100,000 tortillas per day, so we got 200,000 total. And we've got two methods for sampling tortillas. Okay, so method 1 is a random 200 tortillas, just off, from either production line on any given day. And method 2 is we select one of the two production lines. We take 200 tortillas from that production line and measure the diameter of those. Okay, so question is, will a sample of obtained from method 2 be representative of the population of all tortillas made that day? And your answer is, of course not, because if I pick production line B up here at the top, that average is 6.1, and I'm picking all 200 tortillas from this one. If I pick it from A, that average is 5.9. They're going to be representative of that production line. So the answer is no. The tortillas selected will all be from one production line and not representative of the population, since the production lines have different distributions. Okay, straightforward, right? Okay, I think if you simply said the tortillas selected will all be from one production line, so it won't be representative of the population of all tortillas, you'd be fine on that. Okay, next. Okay, kind of all over the place on here, so let's just do B here. B, here's the histogram of the 200 diameters. Which one, method 2, is most likely used to obtain such a sample? Method 1, since it's bimodal, okay, because here's your overlapping, histograms. If method 2 was used, I would expect a unimodal histogram, right? Method 2 is you pick them all from one production line, then certainly your histogram would just be, look like this, right? So I've got 2. This is my 100 from the one, or not 100 because it's not necessarily evenly distributed, but these are my tortillas from one production line. These are my tortillas from the other. Okay, C. Which one, method 1 or 2, will result in less variability in the diameters? Method 2, since the sample will all be from one production line. Right, if they're all in one production line, then they're all going to wrap around either 5.9 or 6.1 instead of being so spread out. Okay, next one. Each day, the distribution of the 200,000 tortillas has a mean diameter of 6 and a standard deviation of 0.11. The samples of size 200 taken from one day's production describe the sampling distribution of the sample mean diameter. The sampling distribution using method 1. Well, method 1, we take them from both, okay, production lines. Well, the sampling distribution, since my sample size is 200, central limit theorem says it's going to be approximately normal. The mean is going to be 6, and the standard deviation is 0.11, which is the standard deviation of the population, divided by the square root of my sample size. Right? Sigma x bar is sigma over the square root of n, right? Which is what we're using there. Okay, oops. So that's all you need is three things to get this right. You need this part, the mean, oops, and the standard deviation. You got to have all three of those. It has to be approximately normal or you don't get credit for that part. E. E's probably when you first read it, it's confusing a little bit. Then once you see it, it's actually straightforward. But it says, suppose that one of the two sampling methods will be selected to use every day for 1 year. So either you're going to select 200 randomly selected tortillas from both production lines, total, or you're going to select one production line and use that. And oops, let me go back here and see. Select one production line on a given day. Take a random sample of 200. Okay, so one day you're going to use production line A, the next line day A, the next one B, and so forth. You're going to randomly pick them. Okay, which method will result in less variability in the distribution of the sample means? Less variability. Well, here you go. Method 1, since the sample means will have means around 6, okay, because that was given up here. Let me erase some of this stuff up here. Okay, it says that the population distribution has a mean of 6, standard deviation of 11. So if I take samples of 200 from the day's production, it's going to be around 6, right? Method 2 will have roughly half the samples will have a mean around 5.9 for those that were selected from production line A, and half around 6.1, which is production line B. So I'll get more variation if I use method 2 than if I use method 1. Because method 1 will get them both, some from production line A and some from B, and the average will be closer to 6. Okay? Make sense? And then F says a government inspector will visit the facility on June 22nd to observe sampling to determine if the factory is in compliance with the advertised mean of 6. Manager knows that with both methods, the sample mean is an unbiased estimator of the population mean. Just means it's a good estimator, a good estimate for it. However, the manager is unsure which method is more likely to produce a sample mean close to 6 inches on the day of sampling. Once you read that, you should go, I just answered that. You're right, you did. Based on your previous answers, which of the two sampling methods, 1 or 2, is more likely to produce a sample mean close to 6? Explain. Method 1, and it's exactly the same reasoning over here. You just explained it, and that's okay to say, hey, it's the same reasoning as part E. To say method 1, and you can kind of recopy that. I don't know if it's on a different. I don't think it's on a different page. It'll probably be on the same page. So you could say method 1 you really could say for the same reason as in part E, and you'd be okay. If it's on a separate page, you could you still could refer back to part E because it's one problem. So you'd be okay doing just that. Okay, does that make sense? I hope so. If not, come and talk to me. All right, we'll see you.